Tonight we're going to be diving deep into A Tale of Two Slicers, Bambu Studio and Orca Slicer, which is a port of Bambu Studio. How the two differ, how the two are alike, and basically why use one or the other, or why use both? Why keep both? We're going to be talking about that. We're going to be going through some just basic 3D printing things. So we were having a discussion earlier on Discord, and just some of the questions that came up were a little to someone who's been doing this for going on 10 years almost. These are the questions that I don't have to ask anymore because they're just I don't really know. It's just domain knowledge now. But for people who are coming into 3D printing who are relatively new, they may not understand what is the difference and why you might want to use some of these settings over other settings, or why you would choose to set some settings to certain values versus other values. So we're going to be going into that tonight. I'm going to be showing you some basic tricks it'll apply to both slicers. Tonight I'm going to be primarily using Orca Slicer, but I will be bouncing back to Bambu Slicer every now and then, just to kind of show you, where the differences are. We're going to kind of take a little staircase up from beginner level and bring it up to the more intermediate advanced level. Not super advanced, but yeah, we'll get into some pretty deep stuff. Okay, so just because of the nature of the way my Mac is with screen capture, the full screen isn't always going to be visible. So I'm going to do my best to make sure that what you see is what you need to see. Here I've got both slicers open. Bambu Studio's on the top, and then Orca's right here. And if you look closely at them, there's not a whole lot of difference right off the bat between the two. Sorry. You've got some color changes as far as you go from more of the bamboo green to the teal, so you don't really see a whole lot of difference when you open them up for the first time. The devil is in the details with these two slicers. So before we get into the really intricate stuff, let's just talk about the basics of slicer settings, just so we can all get on the same page here. You can see over here, let me go ahead and refresh this. So right now I'm on the Prepare tab. Underneath the Prepare tab on here, for both Orca and Bambu, you're going to have your printer selection, your plate type selection, your filaments, and these will all vary depending on how many AMS units you have, if you've got something in the external spool slot, etc. You've got your settings below that. The settings, that's a good place where Bambu Studio and Orca differ, but not in the settings that I'm going to show you at the moment. The settings that I'm going to show you at the moment, those are actually fairly simple and universal across all slicers. And we're going to talk about why we would set them to certain settings to begin with. Just in case you didn't know, you can set up your own user presets for your printers. So I used to have a whole bunch of presets up here at the top: textured plate PLA, textured plate PETG or ABS, textured plate just PETG, PLA on the textured but with low fan. And those had various different tweaks to the stock settings. When you get into your printer settings here, most of those were tweaks to the start G code, and mainly, for the most part, augmenting or offsetting the Z height for either a little more squish, a little less squish. And that's something that you can put in here. It's down embedded. There's a whole lot of startup G code to these. yeah. If you're freaked out already, don't worry. You don't have to mess with these a whole lot, or if ever. If you're having good results with the default default print profiles, then there's no need to get in here and mess around. But yeah, so basically in here you would pop in a code to offset the bed's calibration. So the bed would go through, would do its tap, 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 and then in here there would be a G code that says, okay, take the values of what you just measured and offset it by -0.4 or something like that. And that would give you more squish. Or offset it by 0.2, which would give you less squish. The reason why you would do that is because PETG on a textured surface prefers a little less squish to get good results, and PLA likes a whole lot of squish on a textured plate to get good results. Sorry, my voice is wanting to not stick around, but I got Liquid Death, which should help, despite its name. Okay, so we already know that we can set up now printer profiles that have slightly custom different things in it. You can also set up your extruder stuff in here. So if you find that you're constantly having to change your retraction length or Z-hop or any of that stuff inside of your filament profiles and it's consistent, you can just get in and create a printer profile instead, so that way you don't have to keep messing with your filament profiles, which we're going to talk about next. Filament profiles in Bambu Studio are relatively vanilla. You get some of the more common settings. So you set your diameter. If you're very precise about how you set up a print, you want to measure your filament and get kind of an average over so many feet of the actual diameter of the filament. Even in a perfect world, we'd have 1.75, but even the best filaments have tolerances. So plus or minus 0.02, plus or minus 0.05. And so you kind of just average that out and put that in as your diameter. Then you adjust your flow ratio. That is something that can actually be calibrated, which we'll go through later tonight with some of the more intermediate settings of both slicers. Density and price, those are really more for accounting purposes. And then softening temperature, they don't really use the right word here for me. I know they've changed it to softening temperature, but in reality, what I'm more concerned about is my glass transition temperature. If things are soft in the cage, that's okay as long as it's not reaching glass transition temp, which on PLA is a little higher than 45C. I usually will get in and adjust these to 70, and that's really more for what the bed is putting off. So you cannot adjust your bed any higher than the softening temperature is set for any particular filament that you're printing with. So if I'm going on the texture plate and I know that I have a filament, or let's say, we'll put that back, okay, 45. But let's say that I know that my, well, they actually changed it a little bit. I'm pretty sure I can get away with that now. So it used to be that you could not set your plate value higher than your softening temperature value. It would throw up a big message and say, hey, 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 you're going to melt your filament. It's like, no, I'm not. It looks like that in an update they did finally come to the realization that bed temperature does not equal chamber temperature. Hey, Nomi, welcome in. So knowing that bed temperature doesn't equal chamber temperature and that the chamber temperature usually lags several degrees behind what your bed temp might be. And it also depends on what kind of ventilation you have in play. If you're opening your door, if you've got your glass riser on there, that makes a big difference as to what the chamber can achieve as far as its internal temperature as well. So the softening temperature, if you ever run into an issue with having to crank up the build surface and it gives you an error that it's too high compared to the softening temperature, just up the softening temperature a little bit and you'll be good. Also inside of Bambu Studio's filament settings is your ability to change your nozzle parameters as far as temperature, your min, max, and then what it's actually going to use. You can change your volumetric speed, which is something that is also something that you can calibrate. So we'll get into the calibration stuff here in a bit, but we're just going through the basic stuff first. Okay, with the cooling on the Bambus that have auxiliary fans, you can set the auxiliary fan speed in here for any given filament. Obviously, if you are printing with ABS, ASA, nylon, and even PETG, pretty much anything other than PLA, you'll probably want to run your aux fan at 0, which is not running at all. Other than that, you can set your actual cooling fan thresholds here and your minimum print speed. And then you've got some settings overrides. So if you're printing with a material that, let's say TPU, let's say you got some TPU, and their retraction settings on TPU are crazy. Sometimes you need crazy high retraction, sometimes you need like barely any at all. But in order to figure that out, you have to be able to change your retraction. So your two options are to either change it in the machine profile, which is not fun because that's going to apply it to every filament, or within the filament profile, you can do these overrides and override the length of the retraction, retraction speed, deretraction speed, and dial it in that way until you get perfect retraction on just that filament. You can also mess with stuff like wiping and the retract amount before wiping. Wiping is pretty much just, it'll retract a little bit and it'll keep going around its loop without actually still applying pressure to the nozzle. So basically it's letting that little bit of ooze wipe as a layer line or whatever feature for just a smidgen, so that way you get a cleaner seam and you also get less stringing with that. In the Advanced tab, you have a lot of filament codes here. You can, pop some stuff in there if you want to. The air filtration codes in here. So if you actually need air filtration, like this is PLA, so no real air filtration required. But if I'm going to pop down to, let's say, let's just go to one of the default system profiles to ABS. We need to make sure that active air filtration is turned on, this is where things get weird between Bambu and Orca, because I'm not seeing the filtration setting in here, and I've got it turned on advanced. Interesting. So there's an internal mechanic that determines whether or not something needs filtration or not. So Bambu Studio does that. Let's take a little look real quick while we've got it open. Let's just go into the same settings here. Now, this is the same filament that I was messing with before, and as you can see, I now have the ability to check mark if it's a soluble material. Does it, wash away with water? Is it a support material? You got your normal diameter, your flow ratio, and then here's the winner chicken dinner in my book. You can enable pressure advance and give it a pressure advance value You can calculate that through a calibration. This is more important when you get into silks and PETGs and ABSs. PLAs will usually stick around the 0.02 to 0.026 range for regular PLAs. Usually a 0.02 PA is, at least on the Bambus, is a very safe place to be. Things change that, so if you're running a tough PLA or like Polyterra or PLA Pro, or like I said before, a silk PLA, you're going to want to calibrate your pressure advance in order to actually be able to plug that value in so it doesn't use the same pressure advance as whatever filament it uses at the very beginning. Whatever filament it's using at the very beginning, when it does its flow calibration, that's the filament that it's pretty much just going to use a default value for every other filament in the AMS. So if you're printing with 4 or 8 materials and the first material is black, you put down the black lines on the plate, it goes and it scans it with LiDAR and it makes a determination of what pressure advance value is the best for it. But what if you've got some silks mixed in there, like I did with this? So my pressure advance value for this silk is different than my pressure advance value for the regular PLA in that print. And if they both would have used the same pressure advance, the print wouldn't have come out looking nearly as crisp or nice as it did. There'd be some really bad seam issues. Anyway, that's one place where Orca takes a step above Bambu Studio, and one of the reasons why I use it most of the time. Also within Orca, you've got the same softening temperature that you can mess with. You've got your same nozzle settings, bed plate settings, max volumetric speed setting. Then you get into the cooling here, and now you have a couple more options to mess with. So now you can do support interface fan speed. You can go and again adjust your aux speed like you can in normal Bambu Studio. But here's where you get to the difference. Here you can actually tell it if you want active air filtration on or off for this filament, which you can click on and then you can tell it exactly, while the print is going, I want it going 70%. When the print's complete, you can put in a different value there. So if you want to run that fan at 100% when the print's complete, you can type in 100% and it'll kick the exhaust fan on at 100%. Sometimes I do that with PLA. I'll keep the filter, the actual air filter, I'll keep the fan at about 5 to 10% while it's printing, and then once the print is done, I kick the exhaust fan on 100% to help move some air to cool the bed and help the print settle a little quicker. You got your same settings in here. There's a couple of extra ones in there we're not going to get into, but same setting overrides. Your G codes in there. You have multi-material parameters in there as well, which we'll see if the new implementations that Bambu's putting in, if these will apply to that. But right now it would apply to something more like ECF or ERCF, Enraged Rabbit Carrot Feeder. Yes. So because that's one of the beautiful things about Orca Slicer is that it does support all kinds of printers, especially clipper-based printers. I'm going to show that real quick just by doing this. Here's my, I don't have my Voron anymore, but here's my FL Sun V400. It's the big Yamma Jamma running behind me. It is running Clipper. Let's pop to the Bambu real quick, because I want to show you on the device tab. This looks pretty normal, right? So there's my X1 printing its heart out with Nylon X. So when I go over to prepare and I go down and I select my FL Sun and I go to the device tab, and it's yelling at me for some reason. I got that. Unless, no, it says connected. Could not connect. Oh. Did you change IPs on me? I need a static IP this thing. Anyway, sorry about that. I don't want to really... So basically what happens when you have it hooked, when you have everything configured correctly and you go to the device tab, it actually pulls up Mainsail, your graphic interface for your Clipper install. And you can kind of see that in that preview window here. So if you're running a Clipper printer, Orca Slicer might work well for you. Let's kick this back to a X1.4. Resync. Okay. So let's just kind of go down and talk about the settings. We already touched a little bit on filament settings and why you might want to manipulate them from the stock settings. You might want to adjust temperatures a little bit. You might want to adjust your filament diameter or your flow ratio based on whatever filament you're printing, and that's where you would do that. When you do that, you save it as a user preset. So like PLA Silk I've got set as a user preset in here. So it's just a couple of different things that I changed for that. What I did is I got the Bambu Silk preset, which is a system preset. I brought that in. I changed the variables that I wanted to change, and then saved it back as a user filament preset. And you can select those presets just like you can the normal system presets that are built into it. So, okay, let's get into the nitty-gritty stuff. Layer height. Your big deal with layer height is going to be, that's what we would maybe call resolution. So the smaller the layer height, the less noticeable your layer lines are. The more intricate details you can pick up and print. And on the other side of that, you can bring your layer height up, and that makes things a lot quicker to print. As the layers are now thicker, there's less layer lines, which means less travels around for the printer. And so if you're needing something fast or something strong, you can use a much higher layer height and get both worlds in one. Line widths. So for line widths, these are the actual extrusion width of the lines that it lays down for the various features that are being printed by your printer. You set a default, and that's what it's going to go most of the time. Our initial layer is at 0.5, and then we go back down to 0.4 for the outer wall. Then you have inner walls, top surface, sparse infill, solid infill, internal, and support. If you want to take notes on some of the best settings that you can do, go grab a piece of paper or open up a notepad or something, because I'm going to run you through some of the settings to change to get better print quality in general. So I should have told you that at the very beginning. Miss Britt, hello. Namaka's in. Or you can start clipping the video. Honestly, though, instead of having to listen to me talk, I would just write it down. That's okay. Lurkers are welcome. I can't be mad any lurkers, because I is one. I usually will lurk in a lot of streams, listening in the background, just to kind of help bring up your viewer counts, and you know, I know those metrics help. So, excuse me. Okay, so if you are ready, let's talk about some of the best practice settings for your line widths. Your default line width, that's okay to keep at 0.42. Your initial line width, yeah, better out than in. Not in this case, I don't think. Your initial line width is also okay at 0.5, although if you're looking for a little bit more detail on a face down print, so for example, this guy, this is a face down print, which means that I put my logo face down on the bed. And that was to give it a better textured surface and make it look really poppy, no extrusion lines or anything like that. But this I could get away with a 0.5 initial layer line, or a 0.5 initial layer width, because it's a big object. Now something like my maker coins, these are tiny and have a lot more small features on them. What? What did I do? Hey, shenanigans. So something like the maker coin, would bring down my initial layer to 0.4. That way a little more detail can show up on that initial first layer. If you're not doing anything like that on the bottom, 0.5 is fine. 0.5 creates a nice solid first layer, and we all know first layers are incredibly important for 3D printing. Outer wall, I always will bring my outer wall down to 0.4. Now the outer wall is the very outer extrusion, so this has multiple, I think 3, this has 3 perimeters, and my outer perimeter on this one is set to 0.4, so it really just, it doesn't over extrude, it makes very nice crisp lines. Honestly, don't need 0.42 or anything like that. 0.4, nice clean outer layers. Your inner wall, whatever. you can have your inner wall set at whatever. 0.45 is not a bad place to be for the inner wall. There's going to be some good overlap there. There's going to be some decent strength coming from that as well. So outer wall for appearance, inner wall, strength, and a little quicker printing as well. Top surface, I always bring that to 0.4 as well. Tendency for the top surface to have over extrusions due to maybe a flow rate that isn't fully dialed in. That, and also if there's any kind of displays or artworks on top of the print, then that top surface, you want to have a fairly thin line width there. Sparse infill, 0.45. You can crank it up to 0.5 if you want to. If you want to. 0.45 is fine. But for that sparse infill, which is your, you know, rectilinear, gyroids, honeycombs, cubics, you can make that nice, big, and fat, because basically that's for strength, and big and fat is good for strength, and it also helps speed things up a bit. Internal solid infill, not usually worried about this one. If I notice that an over extrusion is popping up on the very top layer on a particular print, I will go ahead and take the internal solid infill and bring it down to 0.4 as well. So that way it's not accidentally overlapping a whole lot and making a mess. Support, don't worry about it. Would I publish a printer profile anywhere? We only see your face. Oh, I'm so sorry. I forgot I did not clip back here. Pro streamer. I could publish one of my print profiles. I think it would be more confusing because of a lot of the stuff that I do to my profiles. I wouldn't recommend other people do to their profiles just because it's not necessarily things that you need to worry about. It's not technically things I need to worry about, but I just obsess over them anyways because I'm old school. Anywho, so yeah, let's kind of go through again. Default 0.42 is fine. Initial layer is 0.5 unless you're doing face down prints with, you know, multi-material, stuff like that. If there needs to be some detail there, you can kick that to 0.4, that's fine. Outer wall, 0.4 always. Inner wall, 0.45 is fine. Top surface, definitely want 0.4, makes a much cleaner top surface. Sparse infill, 0.45 to 0.5. Play with it, see if it works. You could use a make a chip profile. Internal solid infill, 0.42 is fine. If you see bubbling up on the top surface, try 0.4 and bring it down. Support, whatever. So as far as line widths, those are what I would call my my Goldilocks zones for most materials. I do change a little bit when I'm dealing with ABS, ASA, or PETG. The expansion and shrinkage of those materials lends me to change my line widths a little bit differently. Other than that, you really shouldn't have to mess with it too much. Okay, you got seam position. This one should be fairly obvious, but finding that it's not. So I'm going to grab just a 3D model here. Oh, let's get a non-functional. Actually, eddy busts would be good. Did I get it in there? Oh, there's 2 pizzas of it. Okay. Okay. So for those of you who like Stranger Things, this is obviously Eddie, the Magnificent. He can be my DM any day, any day. I'm going to go ahead and kick him in blue so we can see him a little better here. Okay, so something artistic like this, and when I say artistic, I mean non-functional. The functional things I would be more like the boxes and tools and Gridfinity, the multi-board, you know, those I consider functional. They don't need to be nearly as clean looking. So, but with an artistic model like this, a well-done artistic model, I can't remember whose model this is actually. I don't know if it's Eastman or Wack. I don't think it's Fotis. It's hard to remember anymore. Anyway, seam position. So if I was to slice this now, I'm going to actually pop this to one of my user presets. Standard reg speed. Okay. No, this isn't the one I use. Yeah. Sometimes it doesn't save it the way I like it. Inner wall 0.45, top surface 0.4, that's right. Sparse infill 0.45, yep. Okay, now that's closer. But 0.24? Okay, no. So if I wanted to do this in a little bit, if I wanted to get the best quality out of it, and I can actually show you the print. This was done out of Matter Hacker's quantum filament. So it's the pink to purple transition, which is cool. As you can see, he's got a lot of detail on him. I did this at, thank you Liz, I did this at 0.2 layer height. I did not do the pressure advance test on it, and you can see in the back, actually let me get the macro cam. You can see that nasty seam line on the back from where I didn't do the pressure advance on this and I paid for it. There's also some overhang issues here and another nasty seam line there. So his face is pretty good, and the Hellfire Club shirt's pretty good. That little patch at the top is pretty bad. Anyway, yeah, so all in all, not bad, but could have been way, way, way better. Pressure advance, if you're familiar with the term linear advance, pressure advance is the same thing. And basically what the two do, they are algorithmic in nature, but it's maintaining a continuous flow until you start reaching certain features. So if you're about to take a 90-degree turn, let's say that you have that consistent flow and you're taking that 90-degree turn. Now, if you do it without pressure advance or linear advance, those turns tend to be rounded, because that's the nature of how, if you're extruding at the same volume that you're doing that straight line, it's going to have a tendency to almost spill out and create an arc instead of a nice sharp angled 90-degree angle. So what they did is they ended up implementing first linear advance, which is like I said, it's an algorithmic formula that the slicer uses to determine at what features and at what points, especially the seam point, does it need to lighten up on the flow just a little bit to make it nice and clean. And then it also knows exactly how much flow it needs to lighten up on. That's part of the calibration process, which I will show you how to do in Orca, at least, because it's technically in Bambu Studio, but it's not as easily to use in Bambu Studio as it is in Orca. But yeah, pressure advance and linear advance are ways to make small details better quality, to make corners better, and then also to make the seam better. And so if you don't have good pressure advance, you get all kinds of weird artifacts, especially when printing with things that need a decent amount of pressure advance, like silks. Silks require a lot higher pressure advance value than your normal PLA because of the nature of the elastomer that makes a silk a silk. So, and then your TPUs are going to take just ridiculous pressure advance values. PETG and ABS and ASA are all going to have different pressure advance values. Like I said before, most PLAs that are your basic PLAs are going to have the same pressure advance value. You can also kind of apply that over to like the different I don't know what you call them, series. So your silks. So if you have a bunch of silks from the same manufacturer, in my case I have a bunch of Polymaker silk, I usually will only generate a pressure advance test for one of them and use that for all of them. But again, my silks are going to be different than my PLA regular, so I needed a way to tell it, don't use the same pressure advance value for this as you do for this. And that's where Orca came in beautifully. But I will show you how to do it in Bambu Studio, and you're going to kind of kick yourself a little bit for how ridiculously wasteful it is. So yeah, let's get to the seam position. First, if we do aligned, basically the aligned seam position is going to be the slicer's choice. where are you going to, concerning your shirt, I have considered getting a second opinion. Have I considered getting a second opinion? I don't know. I feel it's kind of accurate some days. Anyway, so aligned seam position, basically you're giving control to the slicer to say, find the best way to place the seam in areas that will be relatively unnoticeable and try to keep the seam aligned. A lot of times it will do that around corners, around other features where it doesn't feel like it's going to be noticed. So let's go ahead and slice them now and see where it puts the seams in aligned. And this might take a second because this is a fairly complex model. 1 million triangles. Holy smokes. It's taking its sweet time with this one. Yeah, I'm going to stop that. You can always right-click on your model and simplify model. You'll get this little pop-up that says, hey, you want to take it down a bit. So I've got over a million triangles, a million mesh triangles in this one model, which is a whole lot. There is 1,298,402 mesh triangles in this particular model. Now I can take the detail level and adjust it. If I adjust it to extra high, the decimate ratio, which is the amount of triangles it's going to try to eliminate, 6.42%. I can take it to extra low, which is a decimate ratio of 92.44%, which is going to make it look like a potato. And you can kind of see it giving, let's take a look at his face. Just watch his face as we adjust. Extra high, nice smooth face still. Not a whole lot of triangles were removed on that one. So let's go to high and see what it does here. Okay, so it's a little more rough, but still not bad. And we're now below 1 million triangles. Now we go medium. You see it's a little bit more rough. Most of the stuff's still pretty good detail. And now we're down to 259,000 triangles, which is going to be a whole lot faster to slice. So let's go ahead and slice it. You gonna make a dum-dum out of me and just take the same length of time for medium? I swear Orca slices faster than this. There we go. Yeah, that will mess you up. Mashed potatoes. Okay, so we are on the line type here, and I know I'm in the way. I'm going to bring this down a bit so you can see it. Here's a really cool tool that you need to be aware of. On the preview pane here, you get the option of choosing a whole bunch of different things that you can see the slice parameters for post-slice. So the line type gives us an idea of what is going on with the print. All that orange, if we look over on the key, it says outer wall. So yeah, okay. The outer wall is in orange. What is all these blue spots around here? Well, those are overhang walls. Now, depending on the severity of the overhang, that might make me consider using support. But I'm not seeing anything that looks crazy in that realm. I think that my printer is capable of handling that. We can go down to the filament, and if you're doing a multi-material filament, peekaboo, welcome in. If you're doing a multi-material filament, multi-colors, it'll show you exactly the lines drawn for those colors. This is a good way to see if your paint job, if you did a paint job, if you messed that up somewhere, you need to cover something else. It gives you a really good look. It also gives you your values for each filament. So like for filament 3, I know I'm going to be using 242.99 grams. That's based off of the weight that I gave it earlier. It's going to tell it's 81.47 millimeters or meters. Sorry. So yeah, there's no filament changes in this model, and then I also get my print time and prepare time. Speed. This is one I use a lot. When I want to know if the printer is behaving the way that I wanted it to, this is what I look at. So I want to know first, well, we got to get to that actually. We got to get the speeds. Anyway, this will tell me, and I can, cross-section the model and see the speeds. Obviously, the infill speed on that is going to be a lot faster. That's a whole lot of infill for this that it doesn't need. But the speed window will tell you exactly what speed any given thing is going. So you can see over on these overhangs around his chin and his nose and on the sides, we're slowing down considerably to be able to print those with high detail. Also very good for clear PETG, yes. If you're using variable layer height, which you can use variable layer height, this will tell you where exactly your layer differences are happening at. I don't use a whole lot of variable layer height. I like the same layer height throughout. I have done it in the past on certain models, but if I know that if I print, for example, with him, if I decided that I wanted his face to be a much smaller layer height so I could preserve more detail, that means the hair behind here would also be in that same very fine layer height. But then once it gets to the top, the layer height might increase, and down here at the bottom, the layer height might be larger as well, which means that in between here and here, there would be a weird looking patch of hair in the back. And that's just one of the reasons why I like to keep it kind of even throughout the entire thing. Variable layer height is great for a lot of things, and it's something that I can go into in a later stream, but at this point I'm not going to worry about it. Line width, we talked about that. Flow, you can see your flow metrics. And this is millimeters cubed per second. So that's basically how fast your extruder is pooping out the filament. Layer times, this gives you an idea of how long each layer is taking, or is going to take. Fan speed, that's another big one for me. I do a lot of variable fan speed stuff, so with PLA, no big deal. It's 100% all the way up, baby. But with other filaments, I'll have the fan varying all over the place depending on layer time, depending on overhangs, stuff like that. And so I want to see if it's actually doing that. Temperature, you don't really have to use this one much, or if ever, unless you're swapping filaments that use different temperatures, and good luck with that. Anyway, we'll just put it on line type for now because that's what I wanted to show you here. So, you have the ability to check mark and uncheck mark all the stuff over here on the side. I would definitely say don't check mark, travel, retract, untract, or wipe, because it just gets into muddying things up a whole lot. Yuck. You can see all the wipes and all that. But one thing I am very interested in is the seam position. Where is it going to place all the seams for all this stuff? Well, as you can see, most of the smaller writing and stuff, and then his zippers on his jacket, all those are going to have individual seams because they're individual features. But what about like his body? It's placing the seams for that entire layer over here on his zippers, which is going to make a mess. So what if I don't want that much of a mess on the front? I don't want all these seams on the front, but for the most part they are aligned. Bambu Studio did its best to say, okay, I can see that we have a good place here for a seam, and this is all the same, so maybe it's a good place for a seam to hide it. And then with the hair, just various seams throughout the hair for different layers. I don't want to do that. So let's take a look at a different seam option. That was aligned. We're going to go back. The back seam option is my favorite. It puts all the seams that it can in the back. So all those crazy seams, it's going to try to push as many seams as possible to the back. It's not going to be able to push all of them to the back because there are some things up here that are going to be unable to seam at the back. But we got far less seams that are random and a nice consistent seam down the back, which when I'm displaying this, I'm not going to be displaying the back. So, oh, he's wearing a Dio jacket. Yeah! There's another option. There's actually two more options. Nearest, this is if you're printing something and you want to print it as fast as possible without giving a care to the wind on seams. Nearest literally is the nearest seam that it can lay down from the last layer. So it's built for speed, and it doesn't always produce a good result. The other one is random, and that's exactly what it is. It's completely randomized. It's going to just randomly place the seams all over the model. Look at that. Every little dot is a seam. It's random, completely random. Now this can help hide seam lines, because then you don't have a distinct seam line. However, if your pressure advance or your flow ratio or anything like that or extrusion ratio isn't set just right, you can end up with a void or a blob at the point of the seam, which means you'd have a lot of blobs or pits doing it this way, especially on the front. And you know, I'd rather just have it on the back. So we're just going to go on the back. Precision, that is a very advanced topic which I'm not going to go into tonight. It has some amazing settings that you can use, especially for mechanical prints or functional prints. The one that I would say that you're most apt to actually use is the elephant compensation. Elephant compensation just helps knit. You know, you get too much squish at the bottom of the bed, and it creates like a little foot. So elephant foot compensation basically dials back the extrusion a little bit, so where it doesn't, at least on the walls, it doesn't create the foot. And that creates a better looking print. So usually 0.2 is a good enough value. If you're still getting elephant's foot on your prints, you can go higher with that. Or if you find that your prints are actually, you know, go sucking in a little bit at the bottom, you can go lower. Ironing is, it's a finicky setting, to which I am also going to consider that an advanced setting for a different day. For those of you who don't know what ironing is basically the nozzle barely extruding on the very top surface of your print. It's a way to try to make the top of your print look like the bottom of your print. Nice and smooth, no layer lines or very, very, you know, dim layer lines. Make that top nice and smooth. When it works, it's awesome. When it doesn't, it produces vomit. So we're not going to go into that tonight. We're going to just pass that one for now. I will do a more advanced, just like advanced D&D, I will go into advanced Bambu and Orca. Wall generator, this one is important. So usually out of the box, you've got Classic turned on. Classic is a fairly straightforward way to generate the various extrusions for the walls, and even, I don't know why they call it a wall generator, because it's actually just an algorithm for extrusion in general. So the Classic one maintains line width throughout the entire print. So if you have your top line width set to 0.4, it is going to use a 0.4 line width regardless of whatever features you have. If you've got very tiny text, then if you use the Classic generator, you're probably going to lose a lot of the detail in that text. That brings us to the alternative, which is Arachne. Arachne comes with a whole host of other settings. Most of these you can leave alone. In fact, I would say when you're beginning, just leave them alone. Arachne is a whole new generator algorithm that takes into account smaller features and adjusts line widths dynamically, line widths and extrusion dynamically. This can make things that were previously unprintable at 0.4 width or higher printable, because now it will try to squish down that line width just a little bit to make that feature pop, and then also all the various features of it that make it a thing, like a letter, you know, it fills it in, it tries to make it work. And so I tend to always keep my slicer on Arachne. Yeah, pop quiz in 5 minutes. I tend to keep my slicer on Arachne all the time. If you're using Prusa slicer, you're probably using Arachne all the time anyway. It's just a... It's a newer, and it works for me, especially on models like this. I usually, if I don't care, if there's not any small stuff and I want things to go faster, I will click it back on Classic. So a lot of the functional stuff I print, Classic is just fine. But when you got details, like on this model, when you've got like the zipper details, you've got the patches, and you've got text there, you've got hair, Arachne will really help dial in the extrusion width and the flow ratio to be able to make that accurately as possible without just saying, oh, I can't print it, so I'm going to just make a zag. Order of walls. I don't know if you guys can see that. I think you can. Order of walls is something that you will probably only face on functional prints that need very tight and accurate tolerances. So, I'm going to go to the main cam here. In a normal stock setting, you are going to have your inner walls print before your outer walls. So, for example, where's my Eddie bust? Where did I put him? Oh, he's over here. So, for example, on the Eddie bust, all of the internal walls, the ones that you can't see, were printed first, and then the external wall was printed last. The reason why that is a good method for something especially like this is because you've got to have those internal walls before you go to your external wall to help with inclines. if you were to print the external wall first, you'd be printing in almost midair. There'd be really nothing for it to overlap against. So for models or things that have crazy, you know, inclines, you want to always print your inner walls first and then your outer wall last. Which is this one. I have mine set the other way, sorry. But inner to outer, that will give you the best looking print, and it will handle overhangs much better than outer inner. What outer inner does, it prints the outer layer first and then prints the inners on that. This stream will be on demand after it's done. I don't know how long it takes for it to get on demand, but yeah, it'll be on demand. So inner and outer, the outer wall will print first when you do outer first. And like I said, murder for anything that has an overhang. But for stuff like boxes or functional things that don't have a whole lot of overhangs, it will give you much better tolerance for the prints. For example, I've got this little holder here, right? So with this holder, it doesn't have an overhang. It does have a ramp going up, but that's not an overhang. It's going the other direction. So I don't have to worry about that. So something like this, I print outer inner because I want the tolerances for like these SD cards to be as close to what the model is as possible. You run into a little bit of trouble when you try to print something that's already tight. When you've got a model that's already tight in the tolerances, you run into a problem when you print it inner outer, because the inner has a tendency sometimes to over extrude a bit, and then your holes and stuff like that end up being a little bit tighter than they would if you did the outer perimeter first and then worried about your inners. So things that you need dimensional accuracy on, if you can get away with going outer inner, that's the better setting. For most models that you do that are decorational, artistic, stuff like that, you want inner to outer for getting the different features to print out better. Even in some of the dimensionally accurate stuff, like this chip holder, there's a lot of overhangs on here. So going outer to inner would cause those overhangs to look like poop. So don't worry, ma'am, it'll be available on demand if you want to watch it on demand. How can I force inner walls? Sometimes I find it prints out first when I have inner selected. If it's printing an outer wall first, then, well, it shouldn't. I'm trying to think if there's, I know at, like on the first layer, yeah, I can post this one to YouTube if you guys want me to. It just, they tend to be long, and YouTube's just not the place where people like long videos. So, and I'm not editing things. That's why I do Twitch now. The only time I know that it will do an outer layer only and no inners is that if you've got that selected in your slicer, you can actually tell it to only one wall on first layer, and it will only put one wall on the first layer. And I can show that here real quick. I should have dialed down. Hold on. I'm going to rectilinear, and I'm really going to chop down that. And I'm bringing my wall loops down to 2 just to speed this up. We're going to get into that here in a second. Arachne also slows things down quite a bit. Just a fair warning. But if you want to preserve that detail, you want Arachne turned on. But while it's doing this, I'm going to take a drink. Liquid Death needs to sponsor me. I would just take free Liquid Death. That just sounds bad. Give me Liquid Death! Give me... No. Okay. So if we go down to the very first layer here, whoop, you can see there's only one perimeter, period. And that is kind of like a cleanliness thing. You also have the ability to do that on top surfaces as well. So instead of having, instead of looking at a top surface and you look at the perimeter and it's like layer line, or not layer line, but wall, 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 you now only have one wall and then your surface infill on the top, which makes it look a whole lot cleaner than wall, 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 wall infill, especially if you're printing with a lot of walls. I mean, for example, the guitar has a single wall on the top, and it's got 5 walls underneath. So if I was to keep that going all the way up, you would see the 5 walls printed here, and it would look ridiculous. Whereas I have one wall and then infill, the solid infill. And so it produces a much better product in the end. Yes, Stephen, it does make the small text look sharper, or just makes it look turn up, period, depending on how small it is. You find it happens with inner overhangs like when I'm bridging screw holes. Oh! Well, those are bridging parameters. So a lot of the times with bridging, it will, depending on what it's needing to draw, it's going to create a perimeter, and then it's going to bridge that perimeter with overhang infill. So it doesn't always do that in the right order, but in the same boat, it doesn't always do it the right way the other way. So with most bridging, it is kind of just what you get. It's doing its best to figure out the best way to keep the filament from, you know, falling down. So if it thinks that by printing at that outer perimeter first and then connecting it, or by printing the outer one first and then printing inners and then connecting the inners, because now you have less distance you have to go with the actual infill bridge, which that might be the reason why they flip it on bridges, now that I think about it. That's less distance for the infill bridging, which is always the punk bridging part. You can bridge perimeter lines all freaking day. As soon as you get to infill bridging, that's the part that usually messes up, because it's no longer going straight across, it's now going at a 45 to the walls. And so it's a little more of one of those moments where something can go wrong. Anywho, I would think that would be the reason why they did that. Your bridge flow is down here as well. Bambu's default bridge flow, I always change it. 0.9 is usually, old school Joe, 0.9 is my preferred bridge flow modifier. And that just basically says, hey, take whatever your flow volume is right now and bring it down 10% for this bridge. Thanks for the gifted sub, Liz. Oh, the alerts are working. Awesome. I was worried about those for a while. And welcome in, Vinny. So, I got derailed. Dadgummit, Liz. Okay. Bridging. On the subject of bridging. You're going to have better results with thinner bridges, just because thinner bridges, at least externally, are a lot easier to rapidly cool in midair by your fan than a thicker piece of plastic would be. I mean, if you look at the difference between the thicknesses of a Sharpie and, say, a pencil. This pencil is much thinner than the Sharpie, so if these are our line widths going across our actual extrusion width period, it's going to be able to cool this less amount of plastic much faster because there's less of it than to cool this one because there's more of it. So you have more chances of your filament drooping if you're extruding more plastic. So traditionally with bridging, you bring down the bridging modifier to about 0.9. Back in the day I used to use 0.8, but that was also back when we didn't have very sufficient cooling. But you can do fast bridging or slow bridging. It really, you just play around with it. Play around with it until you see what works best for the filament that you're messing with. So yeah. What is a bridge? A bridge is a point on a print where there's nothing underneath it, but it's between two spots that can be joined together in midair. So, for example, if you have a hole in your print, okay, the top of that hole is technically being bridged, because the top of that hole is exactly 180 to bed. So it is not being supported by anything. So it's a technical floating region. So what your printer is going to do there is it's going to adjust things, sorry for the hearts, it's going to adjust things to make that actually work. So that's what bridging parameters do. There are other bridging parameters that, let's say that you've got a pole here and a pole here, and it's going to be printing something here. So let's say we have like a block house, right? I've got 2 blocks here. And let's just say that above this, I'm going to build this, right? So one thing I could do, which would definitely be the smart thing to do, is I could enable supports underneath where, let's say there's a plank going across here. I can enable supports from the bed up here, or up to the plank that this is going to be sitting on, and then I don't have to worry about bridging. Or if my printer is well tuned and I got my bridging settings, I can let the printer just print in midair. It's going to literally drag a piece of extrusion across while rapidly cooling it, and then it's going to attach it to the other side, what we call anchor. That's your anchor point at the other side. Then it's going to do it again on the other side, and it's going to keep drawing, and it's going to keep printing in midair over these two because it has 2 anchor points, and then it's going to do infill at a 45-degree angle, or sometimes at a 90-degree angle depending on the orientation of the feature. But it's doing this in midair, and the settings that allow you to be able to do that are your bridging settings. Yes, exactly. The model's named for those crazy suspended models. So the line models that like 3D Print Bunny comes out with, any of the suspended like stuff, they're all using bridging to make the lines that make all that stuff float. It's awesome. I can actually show you some bridging here real quick. So as you can see, we've got this hole. There's a square in the middle. The square here is for the stand mount. So this is actually going to be a void, but it's where the stand is going to go in. So if we keep going up, you can see it's going ahead and it's building out the perimeters. Nice and tall. That's a big stand. Good grief. And then we start bridging. Now, it's not a whole lot of bridging. This is technically not even a bridge. At this point, this is an overhang and that's a bridge. But basically what's happening is it's starting over here, and then it's bringing the filament across here with nothing below it. So it's going to kick on the fan. It's going to do it a little slower or faster depending on which filament you're using. And it's going to make sure that it gets across there with the best flatness possible. Now, Wexter, who's amazingly good at designing models that are specifically in mind for 3D printing, he didn't leave this just a flat surface. He built it up. So it is at an angle, as you can see by the transition. You can see it up here too. So he's got a little slope going here. It's building it up on a slope. Now, it's a pretty radical slope, but it's still a slope. And what that does is it helps bridging. So he knows that if he had just a flat thing right there, it would have to literally bridge across the whole thing, and things can get nasty there. So he does give it a little bit of a fighting chance to where you don't even have to think about it. And then you got bridging infill right there. So yeah, that's usually when you find bridging, it's very small it's very small cookies in various models. It just bridges what it can to that you don't need support. And then you've got the models where it's in the extreme, like 3D Print Bunny stuff, where you are bridging across 200 plus millimeters sometimes. And that's how you can really test your bridging settings. If you can get an extrusion from, well, let me get my ruler here. Okay, from there to there is 200 millimeters, okay? So if you can get your printer to print in midair a straight line from here and anchor it here, and it remains a straight line, you've got your bridging dialed in. Congratulations. If you get your bridging dialed in, you can do some pretty radically amazing artistic things. I will say for Bambu, they've done a really great job of putting in really good bridging parameters to begin with. I still change them because I change things. I'm an old dog. So yeah, your bridge flow, bring it down. There's a thick bridges option here. Now thick bridges is a little bit different. Thick bridges help internally. So if it's something that's not on the external, but you need to bridge something internally, kick that on. It actually makes a thicker, stronger bridge. So, for example, with the two tower scenario, if I was going to have something sitting on top of that plank, I might want to do thick bridging just to make sure that the bridge that it makes is very stout. Thick bridging does have a higher chance of slooping down a little bit or drooping down, but it's going to be far more strong in the long run than a regular bridge. And I have found that a lot of times you can just cut away the droopy parts because not all the parts droop. So that's what thick bridging is for. One wall on top surface, we talked about that. One wall on bottom on first layer. I would recommend turning that on if you're doing face down prints. So like that. Having one wall turned on for the first layer, only one wall on first layer. That setting, if you're doing face down prints like that, so the coasters, the maker chip, stuff like that, it will only create one perimeter wall around everything, and it will make it look a lot more crisp and professional and pretty. We like pretty things, don't we? Okay. Let's go into strength. We can kind of glaze through these a little bit because these are going to be more, they're going to change, but yeah, you don't need to know a whole lot about this stuff. Wall loops, that's the amount of perimeters that you need. So I always print default 3 wall loops, no matter what it is. I do that because printing 3 wall loops ensures vertical accuracy, as opposed to 2 wall loops, which sometimes can leave things a little bit wanting, and then you need something that actually has to help you with your dimensional accuracy there. As far as your top and bottom surface patterns, monotonic is what I tend to stick with for most things. You can get creative, especially with the bottom surface one. Concentric creates a really cool circle pattern, so like on your maker coins, if you want to try concentric, you can. And then like coasters and stuff, concentric could make really cool that way. You have the option of either telling it, I want 4 top shell layers, or you can define a millimeter value. So I want it to be 1 millimeter or 4 layers. I'm not entirely sure which one overrides which. So right now we're printing at 0.2, and 0.2 layer height is going to give me times 4. That's 80. So that's 0.8 millimeters. So is it going to go with the 1 millimeter, or is it going to do 4 top shell layers? That's a question I don't have an answer to for Bambu Studio. I need to just go ahead and do that. Internal solid infill pattern. Well, first off, let's talk about why you would use more or less shell layers. Your bottom shells are less important. Why is my phone blowing up? Oh, okay. It's already 9:32 here. Time flies when you're having fun. Anywho, the reason why you might want more top layers versus bottom layers, and for this, I'd kick up to 5. At 0.2, 5 is a good number. If you're printing at a lower layer height, kick that up even more. Every top layer that you put on there is one more layer that can cover up any issues with any of the previous top layers. So if things are bubbly or droopy in the infill in the first 2 or 3 layers, that 4th and 5th can come over those with a little bit smoother, and then eventually it just evens out to nice and smooth. This becomes incredibly important when you're printing very tiny layer heights. Because if you think about it, if you're printing at 0.2, or if you're printing at 0.12 layer height, that means that the height of that one layer is only 0.12 versus 0.2 or 0.24 or whatever else. That's a very, very thin layer. So you're going to need more of those to equal out, because let's face it, when you put down the first of the solid layers, it starts sagging into infill. It's not always connected completely, and that gets, you know, fixed as you go up in the layers. So using more top layers is always a good idea. Bottom shell layers, 4 is enough for 0.2. You can use your own discretion. Usually don't have the same issue with that, because that's the first thing to get laid down, and then the infill's laid down on top of that, instead of the other way around with the top shells where it's being laid down on top of the infill. So it's basically bridging. Excuse me. Okay. Internal solid infill pattern. This is a good question. This is the question, what infill do I use? Hold on one second. Sometimes my first layer seems to ripple. If I change the Z offset, it seems to go away. What could be causing that? You're too close to the bed, and that's why. If your first layer ripples, you're usually too close to the bed or over extruding. Those are your 2 normal scenarios. And the 2 fixes to that is to either adjust your Z offset a little higher, or adjust your extrusion multiplier lower. You can also play with the line width for that first layer as well. Hey, you know, we all have to ask the questions. I sure as heck did not learn all of this on my own back in the day. It was definitely a community effort of learning from each other and being like, oh, that's how you got rid of that? Well, okay, I'm going to do that now. But let's just quickly go through internal solid infill pattern. This is the infill. Rectilinear is good enough for just about anything you want that's not going to be structurally bearing or needs to be super strong. Rectilinear, I really wish I had... Oh, I have sanding sticks. I can show you this in real time here. Demonstration time with Joe. I'm going to show you how the infill patterns are laid down. This will be fun. Okay, I'm going to bring this out a little bit. Rectilinear infill is laid down like this. One direction on one layer. Oh, don't scratch my Mac. Okay, and the distance between the lines is your density. So the more dense you set it, the closer the lines will be, the more numerous the lines will be, okay? So let's just say we've got a density that's about that, which I don't really know what that would equate to. But on one layer, we're going this way. On the next layer, we're going this way. And the same distance. I'm having difficulty with these sticks. And then the next layer, we go this way. This is rectilinear. So you're building basically lines, and then lines on top, and then lines on top of that. Is it the strongest? No. But if you're doing something like a bust, it's perfectly fine. It just adds that little bit of weight and also a little bit of strength to the bust. It also adds areas that you may need for laying down top layers later on. So, I'm sorry, that's not internal solid infill pattern, that's sparse infill pattern. We're talking about sparse infill. I need to make sure that you guys understand the difference of that. The internal solid infill pattern, that is the infills before the final top. That's monotonic is probably your best for that. It's the sparse infill pattern. So rectilinear is one over the other, okay? Concentric is in circles. So it literally builds out big to tiny circles, just like it shows in there. Let's go grid. This is going to be tough to show. Okay, grid does the same thing as rectilinear, with the caveat that it doesn't wait until the next layer to lay down this line. It literally goes through the infill. So imagine that these are actually on the same layer and there's no raised anything. It's literally going through the existing lines to create a solid infill square. Okay? Grid can be noisy because obviously it's going through the infill lines. I'm not a very good extruder. Well, no, I'm not a very good extruder on many levels. So, yeah. Line infill, never use line infill. Cubic. Cubic is a 3D infill. A 3D infill is an infill pattern that, as it's being built across, it's also being built up. So, right now we've been talking about what I would say is a 2D infill patterns. One over the other, and then intersecting lines. But these are still 2D. As they go up, they're being built 2D, right? So what if you have something that you need support from the other sides of the print? Well, then you need a 3D type of infill that is going to be built up almost like that, or one that's going to change as it prints the different layer heights. It's going to kind of shuck and jive around, creating a 3D mesh on the inside to give it that added strength. Cubic is one of those infills. So cubic, what is happening? Oh, alarm. Cubic is one of the most used 3D infills other than gyroid. And I'm going to show you here what they look like. Hopefully we can do this quickly-ish. Yeah, grid equals everyone's default infill. I don't like grid all that much. It's not really that stronger than using like a 3D, a properly made or properly set 3D infill pattern. Grid is great for getting strength on flat things. But yeah, you can see here with this one, you can see the lines are building up at an angle, creating little cubes. So like right there, we completed a cube right there. So this is an infill pattern that is going to allow us to have more equal strength around the model without using nearly as much infill as well, which is great. If we do gyroid, you'll see gyroid, which is another 3D infill, but it's a very, very special 3D infill. It almost has this like ocean oyster pattern to it where it goes up and then it connects the verticals and the horizontals, connects the verticals, the horizontals, connects, and it just keeps doing this back and forth, which creates a very nice, I think, lattice is the word I would use for this. All right, ma'am, have a good night. Thanks for stopping in. Gyroid is my usual go-to. You've got other types of sparse infill patterns. You're not going to really use a whole lot of them. Adaptive cubic is very good if you're wanting to make sure you have strength where there's strength needed, and make sure that you don't use a whole lot of filament. So like on this one, I might use adaptive cubic because during this spot, I don't really need a whole lot of infill. But as I get up closer, it's adapting a little bit to give me spots that I need that are going to have some kind of a top surface on it. So instead of just printing out into the air to nowhere, adaptive cubic kind of shrinks and expands a little bit depending on what it feels it needs to do. Aligned rectilinear, no. If you're going to do any rectilinear, do the regular rectilinear. 3D honeycomb, this one's another 3D infill type. And it literally is honeycombs. But if you look at them in an isometric view like this, you can see that it's building it up in a 3D pattern. So not only do you get the actual honeycomb this way, you're also getting honeycombs that way. This is a time-consuming son of a gun. Crosshatch, yes. Crosshatch will be, it's in beta right now. Very, very similar to gyroid. I'm curious to test it out and see how strong it is compared. Hilbert curve is just a crazy algorithmic one, and I wouldn't mess with it. Archimedean chords are the same, octagram spiral. All this is stuff on the inside, so unless you're doing translucent stuff and you want to have cool infill on the inside, I wouldn't worry about those. Lightning infill, this one is a relatively new one that's a little crazy. Let's say that you have a print that you're like, oh, this could be hollow, except that it needs supports in certain spots internally in order to print correctly. So yeah, here we go. We're pretty much hollow, but what's this creeping up over here? Well, that's the lightning infill. You can see it in the red here. It's creeping out just for the sole purpose of being able to catch the top layers that are coming out on the next layer. And if it, yeah, so that's literally all it does. And you can, if you don't need any strength in your print, but you do need to have that support inside for overhangs that are going inside, then lightning is a great option for you. I just wouldn't squeeze the print too hard. Triangles is a really cool one. It's just overkill, in my opinion. It's a lot more. You're gonna get a lot more structural integrity out of cubic or gyroid. This is just, yeah, meh. So that is the basics of infills and strength parameters for Bambu. Speed. Here's where we get into the weeds with Bambu. Sorry, I'm putting up my sticks. I'm sorry, my extrusions. Speed, speed, speed. We all want to print fast. And we can. We can print very, very fast with a Bambu and a lot of other printers. That FL Sun Delta behind me is capable of 300 millimeters a second plus. And printing fast is great. There are just some inherent issues. Oh my gosh, you guys are getting free Gus time. Gus, why would you do that to them? They have to use their maker chips for that. Stinky kitty, stinky kitty. Oh, Gus. Oh. You stink, man. Please, no one redeem any Gus time right now, because that cat smells. I'm going to recover from that and then continue. Need some potpourri. Speeds. I actually don't want anyone to touch me after I poo. That's like, just get away from me, I feel dirty. Speeds. So while we can print fast, and it's fun to print fast, and in a lot of times you can print fast and be perfectly fine, especially when printing, you know, stuff like maker coins or, you know, things that are going to be numerous, and you just need to start pumping them out. You know, you can speed up and slow down various aspects of printing, so you can make your bottom layer nice and slow, you can make your very top layer slow, and you can make your perimeters slow to maintain quality in this age of speed. Not saying that you can't get good quality from a lot of speed, you just get better quality slowing it down. That's just the nature of the beast. I'm sorry to be the bearer of bad news. There's just way too many components to 3D printing right now still that makes printing super fast not as accurate or as intricate as printing slowly. However, there are ways we can have our cake and eat it too in this case. That's adjusting just the speeds that we need to adjust. And this, I will say right now, what I'm about to tell you is for PLA primarily. For PETG, ABS, ASA, nylon, and TPU, you are going to need to adjust your speeds a lot further down than you want to get really good results out of them. I have printed PLA at ridiculous speeds, and it looks fine, does fine. There's just some layer delamination there. Same with ABS and ASA. ASA I was having a lot of issues with trying to print fast, and I had to slow it down. TPU, don't even bother. TPU, just print it at the speeds that are on the frickin' spool. Just do it. Don't try to print TPU fast. You will have a bad time. Anyway, let's talk a little bit about PLA because that's what we primarily print with. So when it comes to my PLA speeds, my outer wall, well, my initial layer, my first layer, I set to 50 with an infill speed of 95. That is more of an old dog thing where I always feel like I'm going to get the best first layer if I slow it down a little bit. So I bring the speeds down to these. If you're taking notes, these are good notes to take because they produce amazing results, okay? Initial layer speed of 50, initial layer infill of 95. Don't go above 100. The most important ones here are going to be your outer wall and your top surface. Those are going to be the speeds that you're going to want to really pay close attention to. Your outer wall, I recommend, even with PLA and even going ridiculous speeds with high flow PLA, I don't recommend going over 100 millimeters a second on just that outer wall. Now on the inner walls, crank that sucker up as fast as you want that you think your printer can handle. But as far as the outer wall, the wall that's going to be shown to the world, the one that's got most of the intricacies on it that need to be preserved, bring that down to 100. The other reason why you want to bring that down to 100 is there are things in the filament properties that will slow your print down if you don't do it for it. And it's going to keep burning it at the same temperature. So here's a good example. Let's say you're printing a tower, right? And down here, you've got a relatively matte finish. The printer's able to print out super fast speeds all the way up here, and then all of a sudden, at about the top inch of this tower, your printer is hitting a threshold for minimum layer time. So now it's going to start slowing itself down to prevent overheating and melting the layers below it because it can't cool it fast enough. So it's going to slow down right here, and guess what? That nice matte finish that you had going up all the way to here, where you hit your minimum layer time, now becomes shiny as hell. And that's because you are now burning your PLA at the same temperature as when you were printing fast, but now you're printing it slowly. So what you want to do is you want to try to mitigate the amount of time it has that large of a juxtaposition in temperature and speed. 100 on the outer wall seems to be the sweet spot for the Bambu. You can print at 100 and be perfectly fine with most PLAs. Most of these PLAs have 12 to 15 millimeters cubed second flow rates, or flow volume, I should say. And they cool pretty daggone fast. Especially if you've got your aux fan going away and you've got your part cooling fan at 100%. 100 is doable without changing the outer sheen of the print. Like I said, the inner wall, whatever you want. I tend to bring my speeds down a little bit just because, again, old school. Sparse infill, again, that's another one that you can run super duper fast if you want to, as fast as your filament can handle it. Internal solid infill, I do slow down a little bit. That's because it's going to be rolling down next to each other, making a solid layer, going that fast. I want it to be accurate, and I want it to have a very nice extrusion. So I slow it down a little bit more, and then when we get to that top surface, I slow it down to 50. So it is laying down a nice, beautiful, slow top surface, which gives you far better surface finishes than if you rolled at like 150. All right, see shenanigans. So, I guess it's Sean. Sean? Or just shenanigans? I don't know. So yeah, your top surface. Slow that sucker down. Slow it down. You don't need top surfaces that look like they were, you know, raked over with a pitchfork. The other thing I would definitely say is slow down for overhangs. Please click that. It helps. Travel speed. I don't know why my travel speed is 275 for this profile, because I usually burn that at 500. And that's the speed between movements. So when it's going from one part of the print to the other print, that's the travel speed. Acceleration, don't worry about it. You don't have to mess with acceleration on Bambus. They are set. They're set at good values. I wouldn't mess with it. So, the takeaway from the speed section, make sure to slow down your outer perimeter to prevent the changes in sheen that you could experience. 100 would be my max. Slow down that top surface and have a much better top surface. And make sure that you are slowing down for overhangs to ensure that they were given good. His name is not Shen. I didn't think it was. So yeah, those would be the takeaways from there. Support, this is where you turn on and off support. There's different types of support. They're used for different things, really. Normal support's good for flat voids, whereas tree support is really good for supporting features like on a bust or on a very intricate model. And organic inside the tree, you go here and then tree organic. Organic makes a nice layer for some of the spots. I would definitely recommend, if you're going to use tree support, use organic. If you've got something that's flat and just needs to be filled, normal. And I usually go snug, but that's just me. You don't have to use snug. You can choose to have it generate from the build plate only, which means that it won't start support midway up the print on the print. This is where tree supports come in handy, is because tree supports usually will start at the bottom on the bed and work their way up at an angle. Rafts, if you're using a raft, let's talk off camera. If you've got a bamboo and you're using a raft, we need to have a talk. Other than that, your interface distance, your interface stuff like that, really here, if you have an AMS unit and you have support material, so you've got either the PLA support material or you've got like PVA, which is dissolvable, you can set your raft interference to that filament, and then it will only put the interference, it'll only print the interface layers in that material, and that material is either dissolvable or it just breaks away. So yeah, Steven's running at 80 to 100 outer walls. Yeah, it just makes everything nice and even. Okay. So that's the basic settings. Yeah, heck yeah, K1 Max owners are welcome here. Welcome in. Road Rally Race. Now I'm in Bambu Slicer, or Bambu Studio. For the K1, I would actually recommend using Orca, which we're about to flip into here. This is Orca, so Orca, like you can see right now, is incredibly similar to Bambu Studio. Let's go over the places where it's not. I already showed you one area here where you can set your pressure advance manually, which is handy for multi-materials. I already showed you that you could adjust the cooling as far as like your active air filtration, and if you're running multi-material on a non-Bambu printer, you can adjust that in here. Yeah, but other than that, you've got similar items around. If you have a printer that has active chamber heating, you can also control that via this as well, which is something you can't do in Bambu Studio. And I also showed you that you can bring in other printers, like my FL Sun V400, because it is a clipper printer. I can use it in here and take advantage of all of the goodies. But I'm just going to go to a standard 0.4 printer profile. Would have got the Bambu, but build size was just slightly too small. If they bring out a bigger one, I'd get it. Yeah, hopefully they do come out with a larger one. That they kind of are teasing it. Which, it's funny that they came out with the A1 Mini and then the A1. And it's like, here's some bed slingers for you. And we're all like, where's the big one? We wanted an XL. So we're still waiting for that, but if there's one thing that I've learned from printer companies is the XLs take a little bit longer time to come out. Use Orca for my Venture 5M, yeah. Oh, nice, nice. Yeah, Orca is fantastic. You get all the benefits of Bambu Studio, the nice, easy interfaces, and all the other stuff you can do. And it just works with your printer. If you've got Clipper, especially if you've got Clipper. If you've got Clipper or Octoprint or even Prusa Connect, I think is what it's called. Anyway, you still have the exact same settings in here as you do on your regular Bambu Studio, except you got a crap ton more of little tiny crap. Extra perimeters on overhangs? Sure. Reverse on odd? Why not? Don't filter out small internal bridges? Okay. Bridge contour boreholes. Whatever. Small area flow compensation. Oh, that's nice. Anyway, basically what you get with Orca is you take Bambu Studio and you just throw in all the other advanced functionality that you've seen in slicers before. Alternate extra wall. Detect thin walls is always a good one to have on, especially if you're running 3 wall loops. Pretty much the same infill patterns. They do have a new 3D honeycomb, which is a little faster and easier to print on this version. Apply gap fill, that's an interesting one. Speeds. Here's the good part. Here's the good part. Now, this is a stock profile, so don't look at these speeds. In fact, let's just adjust this down to 95. Let's adjust that down to 100. And let's adjust top surface 150. No, that's 50. And then internal top surface is 150. That's basically the ones that I mess with, is right there. You got pegged for typing blue me. Oh, Twitch. Gap infill as well, I will say I'd bring that down to maybe 200 if you're going to go fast with that. I'd say 100 is fast enough for gap infill. If you've seen gap infill go, it doesn't have time really to get up to that fast anyway with acceleration, but it really tries. Slow down for overhangs, same as in Bambu Slicer. Slow down for curled perimeters. Yeah! That's such a great setting. If you don't know what that is, how to explain it? It can happen with PLA and PETG, where when you're building up an overhang, that is to say, you're coming up an overhang, and it's layer, 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 going up this overhang. There's nothing below that overhang, so sometimes you get cool air there. The cool air then causes rapid cooling, a little too rapid cooling, because there's nothing below it to keep it warm. There's nothing to block a draft or airflow. So these start curling a little bit at the corners. And then you go back over it, it pushes it down, and then it curls up again. You go back over it, it pushes it down. After a while, you get this weird nastiness on that overhang. Slow down for curled perimeters makes sure that there's time that if there's a perimeter like that, it's going to go slower around it, so it has more time to actually laminate to the layer below it. It also has time to cool it down closer to ambient, which prevents curling. Such a great feature. And then pretty much everything else is very much the same in here. There is definitely some options that are more advanced that we'll have to talk about in the stream when we get into advanced slicer options. That's going to be a whole nother stream because that's going to take another freaking 3 hours. I will say that when you're dealing in either Bambu Studio or in Orca Slicer, pay close attention to your global and objects menu. These can be really handy, very handy. You can literally build out items, models, inside the slicer, and then you can layer them inside of the objects. You can manipulate specific objects, like I'm going to show you here real quick. I'm just going to drag some stuff in. Excuse me. Why not? We'll just go with some swatches. Why are you printing that way, you crazy loon? Okay. So I'm going to change this to a filament that we can see. And then I'm going to clone it a bunch of times. Okay, now I got 8 of them. I'm just going to arrange it real quick, nothing fancy. Now let's say these aren't all the same model. If they are all the same model, you can get in here, you can go to others, and you can do stuff like enable a brim. So you can enable outer brim only, and it will generate an outer brim on all the models. Now let's say that not all of these are needing a brim. Let's say like this guy is hollow or something like that, needs a brim, this guy needs a brim, but the rest of these don't need a brim. I'm going to basically turn off my brim, and then I'm going to go into objects. And this is the cool part. You can adjust the settings, a lot of the settings, excuse me, per object in these slicers. For example, like these two guys here, which I know are a little more needy, I can kick it up As far as the layer height, I can change my line widths just for this object. I can change seam positions, I can change the ironing, I can change what wall generator it's using, I can change the printing order just on that object. Strength, I can create more walls, I can reduce walls, I can change all these, I can change the infill, I can change a lot of stuff. I can change the speed on this single object. This comes incredibly handy when you're printing out a plate of, let's say, technical parts. Okay, so let's get into some of my functional models here. I'm going to the hollow clock. Just going to drag a couple of these in there. Okay, I'm going to select all these so I can change the filament color. So we have 5 very different models here, or yeah, 5 very different scenarios. Okay, so over here I feel like that one's pretty good. Don't need support. I think my normal settings will work fine for that. This one's flat and also has this part that goes up, so I want to make sure that I've got my quality set to at least 3 wall loops, and I might add another top shell or bottom shell layer to that one just to give it some strength. Also, that one's pretty flat and might be at risk of warping depending on what I am printing, so I can assign a brim just to that object, 5mm brim. This guy here, I can put a brim on it, just an outer brim. This guy here, this needs to be relatively light because it's being driven by a magnet. So I might go in and to the strength tab and bring down, oh, screw grid, bring that down to like 10, right? And then this guy here definitely needs a brim. Now watch what happens. I've got brims on the things I need brims. I've got no brims on the things that I don't need brims on. It's on the same plate. Per object manipulation is huge, 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 huge. Great, great thing. I can't even tell you how awesome individual object manipulation is. It makes things to where you can put a bunch of things on a plate. Like, let's just say, let me go back. Let's say I want to print this guy in the ultimate quality that I possibly can. So I'm going to go in, I'm going to bring my layer height down to 1.2. I am going to change my outer wall to 4. Top surface to 4. As far as line widths, the seam aligned is fine. There's some other scarf joint stuff that's still in beta. We're not going to get into that. I'm going to iron it. I'm also going to click it over to Arachne for a little better mesh analysis. Inner outer's fine for this one, although for this one, since, yeah, this one I can switch to outer inner. So, now with this piece over here, I am now printing it from the outside in. I'm printing it at a much lower layer height. You can see the detail of that versus the detail of that, yeah? And it will have less infill as everything else. So it'll be lighter. So I cannot emphasize enough how much you should utilize the objects menu. When you're printing a plate of parts that need different settings for each part. Instead of doing them on separate plates, you can put them on the same plate and just adjust the settings per object and print them all on the same plate. This also comes in handy when you're stacking things on top of each other. So if you've got a couple of things that you want to assemble into one print and make it a multicolor print, you can actually layer it how you want it to print. So if you want something to appear on the bottom, you make sure it's layered on the bottom, just like you would with Photoshop or GIMP or any other program like that. And even when it's assembled, you can go into the Objects menu and change the variables for each specific feature. So like the JM in this chip is a separate STL file than the chip itself, and so is the QR code. So if I want to, I can adjust just those aspects. I can make the line width smaller to make them more, to pop more, more accuracy. I can adjust the wall generator, so I could use the classic wall generator on everything but my logo and the QR code, thus making things a little faster. The Objects menu is so underutilized, and you should really utilize it a lot more. That's all I really have to say about that. Anywho, let's talk briefly about calibration, and then we'll be done. We're going to pop back to Bambu Studios because Bambu Studio has incorporated a little bit of calibration into their slicer. So it's up at the top, calibration tab. So now you can do a manual calibration or an auto calibration. And when you go into auto calibration, well, right now the external is in there, so I can't do it, but it will ask you what plate you're using, and then all the filaments loaded in your AMS will be here. And then you hit calibrate, and what it'll do is it will print that calibration, slice it. I hate it when it is slicing it. It prints that flow calibration for every single filament in your AMS that you've checkmarked. It prints that on the bed and measures it, and then it saves it local to the printer, which sucks because when you take that filament out, it's gone. You try to put it back in, you are supposed to be able to get in and select it again, the PA value, the pressure advance value, inside the printer, but a lot of times it just doesn't work out that way, and this is that pattern I'm talking about. This is the pattern it prints to calculate your flow variables, so pressure advance and stuff like that. That is a pain in the bottom, and getting those values back stinks. So that's why when you do it in Orca, you can still do flow dynamics and you can still do auto calibration, but you can do manual calibration with the same, you'll still get the same options to do as many filaments as you want to. You can do it one at a time, but now you get a line value and you get to check yourself when you do a manual one. You can see what the PA, what best is for that filament. And then when you find that, you go into that filament and you go, okay, well, I'm going to enable pressure advance for this filament, and I found that 0.02 works well for this filament, and ta-da, it's done. You save that as a custom, like I did down here with the PETGs, you save that as a custom user preset, and it's forever in there. You don't have to do a pressure advance on that filament ever again. And I like that. The other calibration that's built into Bambu Slicer is flow rate. So to really dial in your extrusion multiplier, which is found in your filament profile, your flow ratio, it's an extrusion multiplier. We all know it's an extrusion multiplier, right? But to really dial that in, you can use this test to do that. And so you can see the over extrusion and then under extrusion and what you are trying to get to. And again, the way Bambu saves it's wonky. Whereas I would prefer to go into here and do the exact same thing. Except they add a better way. I know you can't see the menu bar at the top, but there's a dedicated calibration drop-down menu up here. And there's temperature calibration, flow rate calibration, pressure advance, retraction tests, Orca tolerance tests, max flow rate, VFA tests. All these are built into Orca for your using pleasure to dial in these filaments. I would definitely recommend dialing in your filaments. If you want to get the beautiful results that you see on Twitter and Instagram of these seemingly flawless prints, these are the results of people taking the time to dial in their filaments, pressure advance, flow rates, temperatures, and the actual diameter of the filament, measuring the diameter of the filament and averaging it out. The people who have the best success, I always use Tom, aka Filament Frenzy, as a good example of this. He is meticulous in the way that he dials his filaments. He dials every filament in to a gnat's bottom. And the results that he gets shows that. His prints are as flawless as I've seen any 3D prints come off of an FDM machine. And so you can go in as deep as you want to with calibration or not touch it at all. But I will say that calibration pays off, especially when you're dealing with specialty filaments like silks and stuff like that. Anyway, but yeah, that's the big difference between Orca and Bambu Studio. They both operate pretty much the same way when it comes to configuring your print settings. Orca will give you more settings. Orca will also allow you to work with more printers. Orca will also allow you to put in more variables like pressure advance variables and exhaust fan variables, and also give you more calibration options to dial in those variables. So that's why I use Orca primarily over Bambu Studio. Every now and then again I do pop into Bambu Studio because Orca is on what I would call the bleeding edge of dev, where Bambu is stable. So sometimes you'll download an Orca version and something will be broken, but they'll fix it in the next release or the next update. It really depends on how much you go into the betas versus the stable releases, but yeah, I keep both around just in case. Why not? Even though I use Orca most of the time. Anywho, that's about all I have for you guys tonight as far as Orca and Bambu and the tips, tricks, and the tuning of filaments. I'll go a little bit more in depth when I do my advanced stream. That's going to be a little bit further down the road because I want to make sure that I really do it justice. So I'm going to really get it in place with those advanced settings that I've touched, but I haven't really dialed them into where they should be. Anyway, everyone, thanks for sticking around, and thanks for paying attention to my tirade here. Not really a tirade, but I talk a lot and I get into the weeds, and I apologize. I thank you for sticking around for this. Yeah, I really appreciate y'all. Love you. Keep making the world a better place. And let's pop over to the Maker Deck and see what's being built. I know part of my guitar is on there right now, being printed in Nylon X, which mixed results. We'll see. Nylon X is a punk. Anywho, I'll catch you guys later.